All right, so here is a problem that we can actually work out. So we want to write down the various versions of the equations of the line through this point and with this direction vector. And so maybe if you want, you could start by saying, all right, my R naught is going to be the vector 6, negative 5, 2. And then my V, my direction vector, of course, is 1, 3, negative 2 thirds. And so we know the formula for our line is R equals R naught plus TV. And now we just write things down. I guess one thing that I want you to be aware of is that when we think about our generic R, we usually think about R as some X, Y, Z. It's the arbitrary point on the line. And so it's helpful if you say X, Y, Z equals R naught, which is 6, negative 5, 2. Plus T times V, which is 1, 3, negative 2 thirds. And this, of course, is the vector equation of our line. And now from there, we can pretty well write down the parametric equations. So you're just equating components. So the first component, X, equals first component, T times first component. So it's really pretty straightforward. X is 6 plus T. Y is negative 5 plus 3T. And Z is 2 minus 2T over 3. So these are the, oops, let me try that again. These are the parametric, man, I'm just falling apart. It's a Friday afternoon. The parametric equations of my line. And finally, we're asked to find the symmetric equations. And so there's kind of a pattern. You start here, and then you can easily get these. And then from these, you can easily write down the symmetric equation. So remember, you just solve for T in each component. So T is going to be, solve for it here, X minus 6, solve for it there, solve for it there. So you can write, if you want, T equals. Well, most people don't. But you're just equating what T is in each case. So from the first one, I get that T is X minus 6. The next equation, I get that T is Y plus 5 divided by 3. And the last equation, let's be careful, I get Z minus 2. It's going to be a negative, actually, let's wait, we're going to flip that 3 up. It's going to be negative 3 Z minus 2 over 2 if you want to flip it up. Or you could leave the fraction downstairs. And, of course, these, let me try again, are the symmetric equations of my line. So that's how you can write down the various forms of the equation of the line. Let's do one more example in this video. So we want to find 2 more points on this line. So I've just given you now 2 points on the line. As we said at the beginning, any 2 points fix a specific line. And so even though technically I wasn't asked to find the equation of the line, I was only asked to find 2 more points on the line, I'm going to find the equation or a version of the equation of the line. And that's going to allow me to find the 2 more points that I need. And so somehow I need to build a direction vector. I realize I'm not going to graph these 2 points, but I can visualize them as just 2 points in space. And I can easily form the vector that goes from one and ends on the other. And you can use either direction. It doesn't matter whether you go this way or the other way. It doesn't matter. So let's think of this one. Let's use blue here. Think of this point as A and then this point as B. And I'm going to use, I'll just mention that you can use A, B, or BA for the direction vector, V. Whatever, I'm going to use BA. So I'm sorry, AB. So AB in this case is head minus tail. So 3 minus 8, I get 11. Negative 2 minus 1, I get negative 3. And 4 minus 4, I get 0. So there's my direction vector. And now you can pick either point. It doesn't matter which point you pick to be the point on the line when it comes to our equation. I'm going to pick this one because the numbers are just a tiny bit smaller. Whatever, it doesn't really matter. But now we can write down our equation and we could say x, y, z equals, well, we're going to start with our R naught. So I'm going to say 3, negative 2, 4, plus t times 11, negative 3, 0. Now, if you were to just plug in t equals 1, I'm actually, instead of x, y, z, that works, but I'm going to say r of t. If I were to look at r of 1, I'm actually going to get back the other point, right? You're going to get 11, no, I'm sorry, r equals negative 1. So r equals 1 is good. We're good to go. I'm going to get, let's see, 14, then I'm going to get negative 5, and I'm going to get 4. That's a point on this line. And I could also do r of 2, and I'm going to get 22 plus 3 is 25. Negative 6 minus 2 is negative 8, and then I'm again going to get a 4. You can already see this line is living in the z equals 4 plane. If you think about it, the line is living inside this z equals 4 plane. The z is always 4. The point is, we were asked to find 2 more points on the line. As I've written it, these are technically vectors, and so I'm going to go ahead and say the point 14, negative 5, 4, and the point 25, negative 8, 4 are points on the line. And I need you to realize that there are lots of other points on this line. You might have gotten some different ones. That's perfectly fine. We were just asked to find 2 more, and we did.